Back to another one of my videos in my proof series where I talk about why certain things happen in mathematics. Right now we're focusing on why the derivative of the inverse of cotangent of x or arc cotangent of x equals negative 1 over 1 plus x squared. These are the same thing, they're just written differently, and I thought I'd cover both. Okay? So now we're going to start. Let's say we have our function cotangent inverse of x. Now, how do we get the cotangent on the other side? Think of it as multiplying a cotangent on either side. So we'll have, it'll look like this. Because we want to get rid of this inverse, so we bring it over the other side. Okay. If you're familiar with trigonometric and with triangles and solving using trigonometric functions, this should come pretty easily. But if not, that's all you really need to know. Okay. So now we've got to derive this, both sides. First, we'll derive this and use the chain rule. Derivative of the outside. What's the derivative of cotangent? Negative cosecant squared of fx multiplied by the derivative of the inside. It's just going to look like that. Now the derivative of x is just 1, so we write 1. I'm going to isolate f dash of x because what we're looking for is a derivative, so we're going to isolate this, and therefore we'll have 1 over negative cosec squared fx, because we're going to derive negative cosec squared fx on either side, and it'll end up looking like this. Okay? Now, there's a trigonometric identity that says that 1 plus cot squared fx equals cosec squared fx. Therefore, what I'm going to do here, to make it easier for you to understand, is I'm going to bring the negative out the front and have 1 over cosec squared fx. Only because if you have a negative on the bottom or the top, it's still a negative fraction. So you bring the negative out the front and it's still the same thing. Okay? So now we've got cosec squared fx. We have a cosec squared fx here, and it says that it equals 1 plus cotangent squared fx. So that's what I'm going to replace it as. Okay, so we'll use that. Now, derivative will equal 1 over, I'll have a negative at the front, 1 plus cotangent squared fx. Because that is the same as that, according to this. Now, we see up here the cot fx equals x. Therefore, cot squared, if we squared this side, we'd have to square this side. So, cot squared fx equals x squared. Okay? Because, yeah, if we had cot, I'll draw a little bit over here. Cot fx equals x. If I was to square this side, you can't really see it. If I was to square it, I would have to square this side. Therefore, cotangent squared fx equals x squared. So the derivative will look something like this. That's funny. That's what we're trying to prove. Why the inverse of cotangent x, when you derive it, it equals negative 1 over 1 plus x squared, and that's what we got. So I'll rewrite that for you. We have our function, cot inverse x, and our derivative. 1 over negative, that's a bad equal sign, but you get it, 1 plus x squared. Yep. That's your answer. Thanks for watching. I hope you learnt something and have a good day.